Okay, this is Mr. Smith again, and we're going to start with number 13 on the pre-calc review here. And that was finding the difference quotient for a function. Two functions actually. The first one was 5 over 2x minus 4. And you remember the difference quotient is always f of x plus h minus f of x, all of that junk over h. So, let's do this. It's going to be 5 over, instead of 2x minus 4, x is becoming x plus h here, so it's 2x plus h minus 4, minus f of x, which is just 5 over 2x minus 4. All of that junk's divided by h. And we know that we need to multiply this guy by the common denominator, which is 2x plus h minus 4 and 2x minus 4. So we're going to multiply through by both of those. So 2x plus h minus 4 and 2x minus 4. And we got to multiply through by that on the bottom as well. Now if we had square roots in here, we'd be multiplying by a conjugate probably. Oh, that's the next one. We'll worry about that later. I'm getting ahead of myself. Alright, so we're multiplying through by all that junk. And up top, things are going to cancel. The first fraction, when you multiply this fraction here by those two things, the 2x plus h minus 4 cancels. So you just have 5 times, that's really over 5. Let's do that again. Why do you change? Here we go. 5 times 2x minus 4 minus, and on the second fraction, the 2x minus 4's cancel. So we'll be left with 2x plus 2h minus 4. And all of that is over h times 2x plus 2h minus 4 over 2x minus 4. And I promise you, h's will cancel if everything is done correctly. So up top, we're going to have 10x minus 20 minus 10x minus 10h plus 20. All that is over the same thing, h times 2x plus 2h minus 4 times 2x minus 4. Now, let's go to a cool color here. Where's a cool color? Oh my god, I got it. Pink. 10x minus 10x is going to go away. Minus 20 plus 20 is going to go away. So the only thing left up top here, I'm going to move, let's go to the next page. The only thing left up top is negative 10h, and on the bottom it's still h times all that same junk, which I'm not going to rewrite here. It's all same stuff. But anyway, we're multiplying all this out, so now these h's will cancel, and the final answer is negative 10 over all that stuff that's left on the bottom, and we'll write it out here just for fun. 2x plus 2h minus 4 times 2x minus 4. There you go. That's the answer. You're done. Congratulations. Part B. Let's go back to black here. It's root 2x plus 3. And we're calling this dude g of x, so g of x is equal to. And difference quotient is g of x plus h, so that's the square root of 2x plus h plus 3 minus g of x, which is the square root of 2x plus 3. Nothing crazy there. All of that is over h. Now, we want to get rid of these roots, so we're going to multiply by the conjugate eventually. We just can't do it right now, because, again, you need it to be like the square root minus something, or the square root minus another square root, or something like that. This plus 3 is really throwing a kink in our problem with the conjugate. You can multiply by the conjugate, it's just not going to cancel out those square roots if you do it right. So if you multiplied by the conjugate up here, and you cancel out the square roots, that is not correct. This plus 3 and then minus this plus 3 go away. So really what we're left with up top is the square root of 2x plus h minus the square root of 2x, all of that over h. And now we're going to multiply that by the conjugate of the top. The conjugate of the top is the square root of 2x plus h plus the square root of 2x. So when we do that, you should write it out here. I'm going to run out of room on the camera, so I can't fit it in there. But when we multiply through, we're going to get 2x plus h minus 2x over, and the square roots are gone because we multiply by the conjugate, and that's what that does. And on the bottom, we're going to have 2x plus 2h plus the square root of 2x, like that. And up here, 2x plus 2h minus 2x, the 2x's are going to go away. So really we're left with 2h over h times these square roots, and that's when the h's cancel. So the final answer is 2 over the square root of 2x plus 2h plus square root of 2x. Okay, that was 13b. Now we're on the 14, which is these graphs. I don't know how to get a graph on here, so I'm just going to do it by hand, but it should work out fairly nicely. Okay, so let's make, oh, this will be nice. Let's make our axis like this. That'll do. And let's just, we'll count by ones. 1, 2, 3, 4, 5, 6, in case you were wondering how to count that high. I don't know. Now on the test I gave you a nice graph, so it ended up being pretty easy to shape this thing in there. So the first one was y is equal to 2 times the absolute value of x plus 5 minus 3. Now, absolute value, just as a real quick graph, looks like this. Alright, so multiplying by 2 is going to stretch it by a vertical stretch of 2. The plus 5 on the x is going to shift it left 5. Minus 3 is going to shift it down 3. So the first thing I'm going to find is where is this corner point going to be? Well, it's going to be 5 to the left, 3 down. So 1, 2, 3, 4, 5, 1, 2, 3. Somewhere around right there. And now it's just going to make this v. That's all it's going to do. Except usually it has a slope of 1. It's going to go over 1, up 1, over 1, up 1, over 1, up 1. But a vertical stretch of 2 is going to give it a slope of 2. So when we go over 1, we have to go up 2. Over 1, up 2. And if you don't like that, I mean, honestly, if you don't know how to graph something, plug in a few x values. When you plug in x equals -4, right, you get 2 times -4 plus 5 is 1 minus 3. Well, 2 times 1 is 2, minus 3 is -1. There you go. It's really not that hard. And you can plug in a bunch of points and see what this thing looks like. But I'm telling you right now, it's going to have a slope of 2 and going into the right-hand direction, and a slope of -2 going to the left. So we're going to go over 1, up 2. Best I can here on this sloppy looking graph. Same thing here. Over 1, up 2. Over 1, up 2. And it makes a V. You can see that. There we go. When x is 0, you get, what, 7. So 1, 2, 3, 4, 5, 6, 7. And it should go through there. I'm pretty big on finding the y-intercepts because it's easy to do. Just make sure it goes to the right point. And then this, I'm going to try and draw this the best I can with this crazy pen. There we go. Bam. 2 absolute value x plus 5 minus 3. Beautiful, I know. Next one. Actually, let's just undo all this crap. Get out of here. Use the same graph. Haha, there we go. Alright, the next one was log base 3 of x minus 4. Now, I was a little upset that so many people got this wrong. Logs have a vertical asymptote at 0, and they always go through the point 1, 0. So log base 3 of x looks something like that. Okay? And so this is just log base 3. I'm just showing you like the general function. Log base 3 of x. That's what that is. And if x is 3, y is 1, because 3 to the first equals 3. So 1, 2, 3. This point right here has to be 3, 1. Okay? You can also know that when x is 9, y is going to be 2, because 3 squared is 9. Not super important. So this graph is going to look just like the graph we want, except we have a minus 4 up here. Now what's that minus 4 do? Let's do another color. What's that minus 4 do? It shifts it 4 to the right, because it's on the x. It's inside the parentheses. So instead of having an asymptote at 0, like we did over here, we're going to have asymptote at 4. Bam, 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 bam. There you go. And instead of going to the point 1, 0, it's going to go through the point 4, 0. That's right here. And instead of going to the point 3, 1, it's going to go through the point 7, 1. what did I just say wrong here? I want 5. This is 5, 0. I'm sorry. And then it's still going to go through 7, 0, right? So 6, 7, 1. So it's going to be there. And it's going to have an asymptote like this. And just curve through these 2 points. And that's it. That's all I'm looking for. That's the answer. Okay, so that's what logs look like. The -4 just shifts it. That's all. Alright, let's get rid of all this junk. This is probably a little more work than I really need to be doing. But oh well, get out of here. Alright, the next graph is a piecewise function. So let's get on this. Let me see if I can do this. Can I move this thing? Oh my god, that's amazing. Alright, let's move him over here. Let's get rid of these dudes. Okay, let's go back to the pencil. This is a piecewise function. So it's going to be negative 2x minus 3, negative 5, and x squared minus 9. From negative 2, x is less than negative 2. That's what that says. Negative 2 less than or equal to x less than or equal to 1, and x greater than 1. Alright, so the first thing we're going to graph is negative 2x minus 3. That's a line. It's got a y-intercept of negative 3. So 1, 2, 3. That's going to go through here. And the slope of negative 2 is over 1 up 2. Over 1 up 2. Over 1 up 2. Great. You can see the shape this thing's going to look like. But like that. If you can hit the points. There you go. Let me try that again. That was embarrassing. This is probably going to end up being worse. There we go. A little bit better. Now, that's what that now really comes down here, all the way down here too, right? It goes on forever. That's what the line looks like. But I only want that when x is less than negative 2. So, we need to get rid of this part. Whoa, whoa, whoa. Go back. And we also need to get rid of... Let me see if I can do this. We only want it to be negative 2. Well, negative 2 is right here, so we don't want all of this junk down here. So I'm erasing it. There you go. We also want that to be an open circle because its x is less than negative 2, not equal to. So let's go back to red. Shrink you down a couple times. So this should be an open circle like that. Alright, and that's the piece we want. Now the next piece is just a horizontal line. Y equals negative 5, piece of cake. We'll do him in blue. Negative 5 is 1, 2, 3, 4, 5 down here. It starts at negative 2, which is like right there, and it's going to go to 1, which is right there. That's all that looks like. Just a horizontal line. I scribbled it in there, but what are you going to do? And now we want to graph x squared minus 9 when x is greater than 1. Well, we know this is a parabola. We know the zeros are negative 3 and 3. Now we don't care about the negative 3 because we want x to be greater than 1. But when x is 3, this thing is going to go through 0. So let's do this in another color. I don't know, green. When x is 3, there we go. So it's a parabola. It's going to open upward. Great. I had a lot of people, this is a problem I had here. A lot of people just did this. Oh, there you go. There's a parabola. Great. Well, yeah, but that's not what the parabola really looks like. It does go through this point, true. However, where does it start? So let's get that out of there. That's bad. Get out of there. Well, when x is 1, x squared minus 9 equals 1 minus 9. 1 minus 9 is negative 8. So when x is 1, this thing's at negative 8. Now there's no point there because there's no equal sign underneath the less than. But who cares? There's still a point there at 1, 2, 3. This is 5, 6, 7. So 8 would be like down here somewhere at 1. Open circle. And if you're unsure about where the next point is, plug in 2. 2 squared is 4 minus 9. That's negative 5. So it's going to be right here. And it's just a parabola opening up like that. That's what that graph looks like. Okay, we're done. That was the whole test. The makeup test will look something like this. It will be different problems, but it'll be all in the same material. All right, goodbye.